Okay, hello. My name is John Tedesco. I'm Jerry's brother. I'm an electrical engineer, and just demonstrating one of the camera systems that we have here. It's a two-camera system. One is a spotter camera mounted on the same gimbal with the viewing camera, which is a high definition 60 times optical and up to 1500 times digital zoom. And what we've done is we've prepared one camera to remain at a zoom setting, and left the spotted camera basically at its 1:1. This way we can track an object quickly and move the box for viewing. We have basically a spotter box, and I'll show you that on the screen here. It's a blue box, and up on the top there, that's pretty much where it's been calibrated. And you can see that there's a telephone pole, high voltage transformer there, 3000 volts in. It's got a 240 volt split phase legs coming out of it, and you can see the insulators from the 1:1. Now if I go over to the zoom settings, obviously it's a much larger zoomed in image, and there's a lot more detail. So what I can do is I can actually go over to the zoom mode here and increase it a little bit more. And if you can see on the right there, I'm looking at a label, and I have access here. I have a pan and tilt control system here, and I'm actually trying to get a better shot of the label here. And the label itself, let's just move this over. And I can just about read the label. And I can see that it's put out by a company here. It's called, get it for you in a second. It looks like LP Mako, which is the manufacturer of the transformer, and there's a barcode there you can see. So of course we're looking at this from about maybe 150 yards out. All right, here's the image. Here's the 1:1 again, and where the box is, where we have our zoom mode set. All right, I'll go back to the zoom mode, zoom out a little bit. Alright, and this way we can get a better view of the transformer. Now I'm going to take my pan and tilt, and I'm going to move the camera over, and we're going to look at the light, the street light, which is just below the transformer. So I'm going to get that into view, and you can see that I'm looking at the wiring here. Let me zoom that out a little bit more. Alright, get a better view of it. So the side of the transformer there. Alright. Alright, and what I'll do is I'll line up my box here, my zoom mode. And on the right here you can actually see the light, which is into view. It's focused, and most of the time we keep this in a manual focus mode when we're zoomed out that far. So it's a quick maneuvering of the pan and tilt to get on the object, which is detected by radar. We have an alarm setting, and once we detect it, then we can pan and tilt the camera very quickly using a 1:1, and looking at of course, the zoomed in image to identify the object. We also have a device called a vector scope. Okay. Now the vector scope, what this does is it allows me to look at the colors being generated by the object, and it basically puts it into a phase amplitude rotation. So on the display itself, you can see that there are several boxes in there. One here is magenta. We got red. We have blue down here. And we have green to this side over here. Now, depending on what the amplitude is of the intensity of the light, I'll have vectors that'll basically grow from the center point, which is the origin, and stretch out, basically hitting their targets on this 360 degree phase rotation. So the vector scope will actually display, the phase and amplitude of the light coming in, and identify. And this way we can better identify as far as what color it is. If it's an aircraft light, there might be an amber glow, or there might be some kind of a mercury vapor system that it's using. We can identify the characteristics of the light from a distance and identify whether or not it's an aircraft or it's something else. So, and this is something that is going to be rebroadcast on a matrix switch on the large monitor, and there'll be up to 8 different windows in there on the monitor itself, each one showing a different piece of information. The one-to-one image, the zoomed-in image, the vector scope image, the thermal camera image, and we have a UV filter on one of the cameras to just give us a cutoff of the visible light and allow us to extend into the UV. So there'll be characteristics of the object that can be clearly seen. Okay, again, I'm going to demonstrate the pan and tilt. Alright, I'm going to move my box over here. I'm going to get to the top of the telephone pole just to see the insulator. Okay, and if I show you on the zoomed in image, you can clearly see the insulator on top of the top of the pole there. And get a little bit closer in detail here. Let me zoom in, get a better view of it. Okay, so what you're looking at is the insulator on top of the telephone pole. It's clearly defined. I can see the wiring. I can see the twist cables that are holding the wire to the insulator. And of course, on a one-to-one image, it can barely be seen. Now we have optical zoom on this camera, which is 60 times, and we've basically experimented with various different zoom systems. The digital, depending on the resolution of the camera. In this case here, this is a 9.2 megapixel camera. I can get a digital zoom in of about 200 times and still be able to read the writing, especially on an object like this, an insulator. Easily see the writing on an aircraft, the body of an aircraft, at almost 4 miles away.